present two extensions of the Gauche model, just very quickly, okay? And then we can discuss final exam and stuff. All right, so I'm going to begin to record. People are still coming in, but I'll just start to record in the interest of time.
This meeting is being recorded.
Okay, so hi everyone, good evening, good to see you. So last class, I presented the Arch and the Gauche models, and also presented how we test for arch effect. So there were 4 pages of handwritten notes. You have them. Today, I want to present 2 more pages. They are just an extension of the Arch and Gauche. So just 1 second. So I'll do this. Okay, and then I'll do this. All right. So last time I showed us again the following 2 models. Let's see. Okay, so this is the Arch model, which is the Arch model which we have discussed. Y is Arch 1, Arch 2, Arch Q, and all the definitions. So this is the standard Arch model. So we know that we have looked at that, and then we looked at the Gauche model. So how is this different from? How is the Gauche model different from the Arch model? Can anyone remind us?
One is ARMA. The other one is MA only.
Exactly. Thank you.
So Arch is ARMA, right?
The Arch is like an MA model.
MA, right? Yeah.
And the Gauche is like an ARMA. Okay. So the Gauche consists of the variance is this variance on the left-hand side is the variance of the error term. Let's not forget that. But the error term itself, if the variance of the error term on the left-hand side and we have the error term on the right-hand side, that's an arch. But when we include the variance of the error term lagged, okay, so the current value of the variance is equal to constants and the lag value of the error term itself plus constant and the lag value of the variance of the error term. That is Gauche. Okay. So this Gauche model is quite good. It's very powerful, but it doesn't allow, for example, when our observation that when there's good news, some good news, for example, the price of gasoline does something, or the price of gasoline does the opposite. Or like today, Biden, the CDC recommended no more masks. So everybody's euphoric. And when there's good news versus when there's bad news, or if we want to analyze Facebook or Tesla, for example, and there's bad news. For example, Elon Musk went and blew off his mouth about not accepting what What's he not accepting anymore?
Bitcoin.
Bitcoin. So he's no longer going to accept Bitcoin, and that is kind of bad news for Bitcoin, and bad news for the market somehow. Okay, so if you consider that bad news, then the Gauche, this Gauche you are looking at, does not handle asymmetry. That is, this Gauche is symmetric. In other words, good news and bad news are treated with the same effect on volatility. But if you observe the market, those of you who play in the market, you'll notice that bad news many times tends to impact volatility more than good news. In general, that's observation, okay? But in some cases, that's not always, in some cases, good news will have bigger impact. But generally, it is observed that what is important is that there's an asymmetry. Good news and bad news do not affect volatility in the same way. This Gauche model, the one you are looking at now, the standard Gauche model, doesn't handle that. Okay, so we introduce some other extensions of Gauche that are designed to try to distinguish the effect of good news, whatever that good news is. What is the impact on volatility? And to distinguish it from bad news and the impact of bad news on volatility, okay? So I posted two handwritten pages, page 5 and page 6. Those two models are extensions of the standard Gauche model that are designed to be able to handle the asymmetry in impact of news. Whatever the good news or bad news are, okay? And we call that, technically we call that leverage effect, leverage. I think I used an example either last class or last week that those of you who observe gasoline prices and crude oil prices, okay, it's been observed, and I noticed that if crude oil prices go up in global markets, then the price of gasoline in the United States and elsewhere will go up. For example, if a 1% increase in global crude oil prices, not refined, crude oil prices, if a 1% increase in crude oil prices results in a $1 increase in gasoline in the United States, then you will notice that when that crude oil price falls by the same 1%, it went up 1%, but if it goes down 1%, the gasoline prices will not fall by exactly 1%. Typically, they will fall by less than 1%. I know this for sure because I live a few miles away from Princeton University in New Jersey, and I commute into New York, into Port Authority. And those, it's a private operator for the New Jersey Transit. So the bus I take, I also take the train. But the impact, I always feel the impact on the bus, because when crude oil prices go up globally and it's widely in the news, they increase the price of my ticket my bus ticket to go from here to Port Authority. And then there's always this little notice on the bus and in the bus station that says this is temporary. This is temporary. And when the gasoline price, when the crude oil price comes down, that we will go back to the original price. And I have been commuting for as long as I remember. It never happened. In fact, for the buses, it has never happened that when the price of crude oil goes down, that they reduce the price of the ticket. It never happened. Once they hike it, it stays there. Whether the crude oil price comes down by 50% or 200%, no. So those kinds of things we call leverage. Of course, as a finance professor, I notice such things because I'm aware that it happens. All right. Um, so those things we call them leverage effects, and some people like to call them asymmetric effect. Okay. So I have put these 2 pages on Blackboard. I just want to quickly just show them to you, so I can kind of rest assured that those of you who want to continue in this field, that you are aware that there are many autoregressive conditional heteroscedasticity models. There are many of them. All right. So so let me show you. You have this already you have this already in Blackboard, okay? So the first one is what we call exponential Gotch. Okay, that is the one you are looking at now. Again, exponential Gotch or Egarch. They look very complicated, but I want to show you the basic fundamental story. Okay, because it's exponential, we usually would use logarithm. Okay, in the standard Gotch, remember the one I just showed you and the one we discussed on Tuesday, I showed you a little bit on Tuesday, it's only the variance of the error term here. Now, again, for all these models, you can use the same mean model, the same OLS model, autoregressive model. You can use any model that, that we refer to as the mean model. But for that model, the assumption of the error term is that usually we assume it is IID, it is normally distributed, but it is not homoscedastic, okay? Because that's why we tag on this T. So here for the exponential Gotch, you will see that we use logarithm, natural log of variance equal to, now look on the right-hand side here. Let's see. Look on the right-hand side of this equation. It's equal to alpha plus alpha 0 plus alpha times all of this expression. But notice here, instead of the error squared, we're using the absolute value of the error, okay? So we are using the absolute value of the error here. Remember, when you square the error in the standard Gotch, when the error can then, because you have squared it, it cannot be negative, right? You agree. But another variation is the absolute value. So instead of squaring this, we use the absolute value. In other words, it is always constant. And look, here we have the Gotch aspect, because we have the variance of the error term. So we have the variance of the error term here. We have the variance of the error term here, log squared. So because you have this E here and you have this here, this is a kind of Gauche model. Like who said it, Alec or Andrew? Who said it? It's an armor. Okay, Alec, it's an armor. Okay, because you have both. You have the error term is here, and you have this term here. So this is like it has a Gauche component. It is exponential, so we use log. Exponential, which is multiplicative. So we use log to make the components additive, all of this. And so this is a funny, it's an empirical expression. So people have done a lot of work in this area, and they found that this equation works well. But this is the key. This is the key thing here. This gamma. Okay. So let's go down here and see. Okay, so in this case, if gamma is 0, okay, sorry, let me make this a little bit. So what happens here if gamma is 0, right? You see this whole term disappears, yes? You see, right? If this gamma is 0, this whole term disappears. So we are left with this component and this component, which is like a standard, it's like an exponential standard Gauche. Okay, so we say that if gamma is 0, this model is symmetric. Symmetric in the sense that good news and bad news, are not distinct. We can't distinguish the impact of either good news or bad news on the volatility of the error term. And if the volatility of the error term is changing, that means the return in the mean model is changing, because if the volatility changes, the error term itself changes according to the volatility, and that affects the return on the left-hand side of the mean equation, okay? So if this gamma is 0, then this equation is symmetric, exponentially so. If gamma is less than 0, okay? If gamma is less than 0, then positive shocks or good news generate less volatility than negative shocks or bad news, okay? So if gamma is 0, if gamma is less than, this is designed in such a way that if gamma is less than 0, then positive shocks or good news generate less volatility than negative shocks. But if gamma is positive, then if gamma if gamma is greater than 0, then positive shocks or good news generate, let's see, I'm trying to go down here. Then generate more volatility than negative shocks. If gamma is negative here, then good news generate less volatility than negative shocks. Okay, this is if you go to chapter 4 and look at the section on Egarch, there are many types of Egarch models. This is just one type of specification. Here we say that we're looking at this gamma, and if this gamma is less than 0, then good news generate less volatility than bad news. But if this is positive, then good news generate more volatility than negative shock. In this kind of specification, I'm going to show you another kind of specification. And if you cannot see it directly here, it is the way this equation is derived. This is just the final equation, okay? So this is one specification of what we call leverage effect, the Egarch, the exponential Gotch. So here we focus on testing hypothesis whether this gamma is less than 0 or more than 0. Because if it is either, then the impact of good news relative to bad news will be different, okay? So this is one specification. All right, so let me show you quickly another specification, which is on page 6. So this one we call the Egarch. The one I'm going to show you now is called the Tgarch, threshold Gotch. And sometimes we refer to it as the GJR, in honor of the people that suggested it to us. E is Glustin. J, I'm trying to remember, Jagannathan, Indian name, and Glustin used to be at Columbia University. I don't know if he's still there. Jagannathan, I think he used to be in Northwestern University, I think. And Ronco, I don't know where that one, all three of them professors, okay? Just kind of famous professor. Glustin, I remember because I'm in New York. All right, so let me, not really. Glustin was the PhD supervisor to one of my former colleagues in my department. Okay, that's why I remember him. And I think we have invited him to Baruch College, in my department, to give a seminar series a while ago, but I haven't seen him in a long time. Danny, you have your hand raised.
What did you say that letter represents?
Which letter?
The one underneath the 2?
This two here?
No, in the brackets. In the brackets.
This one here?
Yeah, what is that again?
That's pi.
Okay.
I'm sorry, that's my measure of pi. It's just a constant. You know, pi 2.7187187.
Yeah.
Mm-hmm. So the people that designed this is the equation they arrived at, okay? Oh, okay, success, Mr. Murphy, that's good. Okay, good. I was going to ask you. Excellent. All right. Where was that? Okay, so let me go to another one. So the Egarch model is a very specific model, and those of you who you have time, you can read chapter 4 on that. There are many others. There are many other extended arch models in chapter 4. But I pick up these two because leverage effects are really popular, and leverage effects are intuitively, in fact, they are very highly observed in many markets. Okay, and in many markets, what is the impact of news? News impacts volatility of stocks. Okay, so it's either good news or bad news. And so over time, again, it doesn't matter what the market is. The impact of good news and the impact of bad news are not symmetric. They're not equal. Okay. Danny, your hand is still raised, or are you okay? Okay, okay. All right, so let me show you the final model so that we can just get on with. And this one I just showed you. Let's see. Page. So the last one, again, you have these 2 pages in your Blackboard, on your Blackboard site. I put them on, and they should activate by now. So the other one is Tgarch, and T stands for threshold. You know, threshold is usually some level beyond which or below which. Okay, so threshold that's the word. But it was discovered by these 3 guys. I think it's Glostin, Jagannathan, and Ronco. I'm not quite okay. We just call them GJR or threshold. So again, the mean model is the same. So in all these Arch and Gauche models, we like to keep the mean models the same, except for one of them, which is called Gauche in mean. And that we use for when we want to analyze things like capital asset pricing model, but let's not worry about that now. So here, this is the variance equation. Okay, here the variance equation says it's threshold, so it's not exponential, so it's not multiplicative. We do not use the natural log here. So we say the variance of the error term. Again, this is the same variance of this error term. And because the variance is changing, whenever this variance changes, the error term changes either by small or large amount, and that impacts the return on the on IBM or Facebook or whatever. Okay, so in this main equation, it makes a difference whether this variance is constant or whether it's dynamic. If it is dynamic, then every period we have to ask, how does it change? By how much has it changed? And that will determine how much this E changes, and therefore how much our return changes. Okay, all right. So according to the Tgarch model, this is one specification. Here, notice this is really more like the standard Gauche. Variance on the left-hand side. I'm sorry, guys, if you don't understand me well, it's because I have this, I need a root canal. I've been needing it for months. But because of COVID, I cannot go to the dentist. But next week, I'll take my second shot, and then 2 weeks later. So I'm already making appointments. But once in a while, I really cannot talk properly because I'm in pain. I took a lot of painkillers. So if you don't understand what I'm saying, please ask me. But sometimes I muffle my words because I'm in pain. So I apologize for that ahead of time. So look, this is a Gauche model, right? The Gauche model is sigma squared T equals this constant plus this. This is the error term itself. So this is the Arch component, and this is the Gauche component, right? So this 1, 2, 3, and the last one 4. They are the standard Gauche. But for the threshold, we introduce this term gamma, and the error, the squared error lagged. So just like this one. Plus, we introduce a dummy variable. Okay, I'm sure you guys in Echo 4000, you came across the idea of a dummy variable. Is that correct? Can somebody just confirm?
Yes.
Okay, so a dummy variable takes a value of 1 or 0 if something. So threshold The idea of a threshold, usually when we introduce the idea of a threshold, you can use a dummy variable because you want to say whether whether something reacts differently in one regime versus the other regime. So for example, we want to see whether that volatility is different during a recession or during an expansion. So we use a dummy variable, and then we can define the dummy to take on a value of 1 during the recession, and therefore a value of 0 during an expansion, and so on. So thresholds, typically we represent but with a dummy variable, okay? Not always, but it's easier to understand. So here we introduce this term here. And so this is a threshold 1, 1, because it's like a Gauche 1, 1. Here, D1 is a dummy variable with this D1 in the past period equal to 1 if bad news. So if we have bad news, so we define dummy variable as, so we have, for example, Facebook for 20 years, okay? But then within those 20 years, let's say we go from year 2000, okay, year 2000, January 1, 2000 to December 31, 2020, okay? And then let's say we use daily data. But day by day from January 1, 2000 to December 31, 2020, there could be many periods of good news and many periods of bad news. So we define good news as blah, blah, blah. Bad news as blah, 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 okay? And then we look at the data, and then we go through day by day and say, which day was good news according to our definition? For those days, let's define a dummy variable, and that dummy variable takes a value of 0. And then for any day we think there was bad news defined by our definition of bad news, we put the dummy variable 1. So think about the data you guys downloaded for homework. Daily, from January 1, 2000 to December 31, 2020, every single day, each day, we can assign that day as, for each day, we have another column, we call it dummy. For each day, that dummy will have a value of 0 if there was good news, or 1 if there was bad news. So we have the year, we have the return, day by day return, and then we have the third column equal to D for dummy. And the value in that column will be either 0s or 1s. 0s for days with good news, 1s for days with bad news. And then we run this regression, okay? And then we run this regression. Now, on the day of bad news, everybody look at this, okay? Everybody look at this equation. Andrew, give me 1 second, okay? Everybody look at this equation 2 here. If gamma is 0, just like here, that is a day that is not bad news. But just for simplicity, let us say it's a day of good news. Because look, any typical day can be good news, bad news, or just a normal day. But all we're interested in here is either bad news or other day. So, but just for simplicity, I'm saying when it's not good, when it's not bad news, it's good news. I'm just being simple here, okay? All right. So here, if D is 0 here, then all of this will disappear, right? Is that right?
Yes.
Okay. And if all of this disappears, what kind of model do we have? What does equation 2 boil down to?
An arch.
Large.
It's a Gauche, right? Because it has this and
Right.
this. So that's a Gauche, right? Okay. And therefore, the impact will be different from if y is 1. Not y, if gamma is 1. Okay? All right. So
You mean if D is 1?
yeah, I'm sorry, that if D is 1, I'm sorry, yes. Okay. So the impact, yes, exactly. Sorry about that. So if D is 0 is a good news day or a day that is not bad news day, then this thing disappears. Then we have the standard Gotch. If D is 1, then it's a bad news day. Then look, just you guys just you don't need to write anything. Just eyeball this equation. If D is 1, what happens? If D is 1, then we have these two things here, right? These two things. So it will be alpha 1, this squared, plus gamma 1, this squared. I think I made a little mistake here. This should be alpha 1, not, this should be alpha 1, not gamma. Anyway, so if this is 1, then we are mixing these two things here, these two things, and therefore the impact will be alpha 1 plus gamma, okay? But that's just a little arithmetic I wanted to show you. But the bottom line is that what we are testing is we're testing the null hypothesis here that gamma is either less than or equal to 0, or here that this is equal to 0. And so to run this regression, we have these values, we have these values, we have D, and then we have these values, and then we monitor. Our hypothesis would be whether this is less than or equal to 1 or greater than 0. Okay. When I'm not going to do this in this class because we don't usually go there. But I just wanted to introduce you. So these two models are introduced. Bottom line, the story is that the standard Gauche model, or even the arch model, but typically we are focused on the standard Gauche model. It doesn't handle good news and bad news differently. But because you and I observe every single day that good news and bad news have different impacts on volatility and therefore on return. Okay, because so if there's good news, it impacts volatility in the equation, and that volatility will impact the error term. Sorry, that volatility will impact the error term in the so if there's good news, it will impact this, and that's the variance of the error term, and that variance of the error term will impact the error and therefore impact return. Okay, so if it's a homoscedastic model, that is, this variance does not change as t, then whether there's good news or bad news, volatility will be the same. So there'll be no impact on return, which is really not realistic if you guys are even casual observers of the stock market. So, but if this variance of the error term is not is heteroscedastic, then then how does it move? If we have this ability to capture good news or bad news, then when there's bad news, it impacts the error, and therefore impacts return. When there's good news, it impacts this, it goes here, it impacts it differently. That's what I'm saying. And then here, and then here, okay? So if you look at chapter 4, there are many other specifications, but these two are kind of popular ones, okay? So I just wanted to show you that in terms of time series, that it does get complicated in terms of how we handle volatility. If you look at equation 2 here, what is missing? This is essentially deterministic, right? Because I have not included an error term in equation 2. Okay, if I include an error term here, properly specified, then this will be such a specification will lead us into the world of stochastic volatility models. But here, no matter how complicated these variance equations are, as long as we are dealing with arch models, okay, that it's not stochastic, it's deterministic. Okay. So let me stop here. Oh my God, it's almost 6:30. Sorry, once I start to talk, the time goes. All right, look. So what I'm going to do is, I think I'm going to stop. I think I'm going to stop recording, and then we can talk a little bit. Okay. Uh,
Professor,
yes,
I
Danny,
have
you
a
had a
really
question.
question.
Actually, I think Andrew had a question first. Andrew, sorry.
Oh yeah, I did have a question. So
Mhm.
my question was, how do you simply quantify good and bad news?
Okay. So good news. You and I can. I think good news and bad news will depend on how you and I define it. Okay. For example, we can say good news is something that moves maybe Dow Jones Industrial Average by more than 5% or more than 10%. We can say that. That is, good news moves Dow Jones Industrial up 10%. Bad news moves Dow Jones Industrial Average beyond 10%. That's one. That's one specification. It, of course, it is subjective, right?
Yeah, I was gonna say that. What if let's say someone died on a certain day, and
Yes.
then
So
also someone else, there's also good news on that day too. How do you
yes.
just simply like slap a number onto it per se?
Okay, so before we begin to do this experiment, this analysis, we can define the death of a corporate officer. Okay, like a corporate C-suite. You know what I mean? CEO, CIO. The death or injury
Of a
or
chief.
resignation or something. Yeah, yes, the death or resignation or something something of a C-suite, chief investment officer, chief technology officer, chief financial officer, and then from C-suite up. That is bad news. The removal or the exit, sudden exit, is bad news. Hiring is good news, a good one. Okay, or we can say war.
Wait,
Okay.
professor. So what I'm saying is, I know what you mean by good and bad news, but
Uh-huh.
my question is, how do
what if
you
what if there's good
simply?
news and there's bad news? Is that what you're saying?
No, my question is, news is very subjective and complex, and you
Uh-huh.
have this model. How can you reliably just put a value on good and bad news? You know,
well,
like
we're not putting a value, we are just identifying. When, remember, okay, look at this model. Let me go back. Okay.
I thought you said when gamma was greater than 1.
No. I'm saying our hypothesis is
Okay.
is that gamma is either less than null. Gamma is less than or equal to zero, and our alternative is gamma is greater than zero. But we identify good news by the D.
Okay.
We identify the bad news by the D. If it's a bad news day, we're not giving bad news a value. We're just saying if today is bad news, then today's value corresponding to today's return, D will be 1. If it's good news, D will be 0. But
So it's binary.
it's binary, yes.
Okay.
That's why we use a dummy bit. But the impact overall of the bad news days is, then D is 1. If D is 1 in this model, right? Then 1. So this thing here will be gamma E squared T minus 1 plus alpha 1 E squared T minus 1. So if you how do you say, if you bring if you factor E squared T minus 1 out, then the impact of bad news, that is when the dummy is 1, is equal to alpha 1 plus gamma,
All
right?
right. Thank you, professor. I understand.
Okay, you got it. Okay, sorry if it was confusing. Okay. All right. Somebody else had Danny.
Professor, the
Yes.
can you go back to that page and
Okay.
go to the bottom?
Okay. So just Andrew, that was it. So just to emphasize, Andrew got it, but just in case you're still having questions, uh, to emphasize, we're not quantifying good news. We are quantifying the impact of good news. But any day we think there's good news, we put dummy equal to 0. Any day we think there's bad news, we put dummy equal to 1. Okay. All right, Danny, you want me to go down? right?
Yeah. So what I put in the chat was the impact if the dummy variable was 1 is alpha plus gamma times the error term of yesterday, right?
Yes, the way I have written this equation is so look here. If D is 1, if it's bad news, right? If this is 1, right?
Yeah.
Are you looking at if this D is 1, then this thing here will be gamma E squared T minus 1. Just like this one, right? Is that right?
Yeah.
So if you remove it, if you put parentheses here and parentheses here, and you put E squared outside of the parentheses, then you have alpha 1 plus gamma, right? So that would be the impact. That's what I said here. I think I made a mistake here in my writing.
But why isn't the the error term from yesterday on the outside? Right there.
Which one? Here?
Yeah, right there. The error term outside.
No, because then the coefficient of this error term would be alpha 1 plus gamma, which is it's like the beta in the OLS regression. Okay. Danny, you can work this out, but let me okay.
All right.
Okay. Oh, no, just hold on. This is good. All right. So if this is D1, right? If this is D is 1, right? And imagine that we bring this E squared.
I know you're
out.
factoring it out. I got that.
Yeah, we are factoring it out. So alpha 1 plus gamma will be the coefficient of E squared T minus 1, right?
Yeah.
So the coefficient of E squared T minus 1, meaning if that E squared T minus 1 goes up or down by 1, that this is the impact. Alpha 1 plus gamma plus gamma. Okay, so yes, this E squared should be on the outside, but we're looking at, it's like the slope. The slope will now be this thing with factor.
Okay.
Okay, that's what I mean.
Got it. Thanks.
Okay. Sorry, I mean, again, hey, we just got good news today at Baruch College that this administrative staff will return to school the week of August 2. I don't know if you guys got the and then professors will follow, and then classes will begin in the fall. So in the classroom, this is really better for me because I can work it out more easily than writing it out. Okay, Andrew, your hand is still up. You have question? Okay, good. So I'm going to stop recording, okay? Unless you guys have any question related to Gauche. And I want to give some, or do you want me to record while I talk about the final exam?
Yes, Professor. So
Okay.
we could go back to the recording.
Okay. So actually, tonight is the last class, because in my mind, I think last class I was telling you guys that Tuesday was the last class. No, because I teach two other classes in the daytime, but for French students. And they are operating on a different schedule from us. Actually, for your class goes with regular Baruch schedule. And the last day of class is Monday, 17th. So our class is on Tuesday. But I was using Tuesday of next week to tell you guys that on Tuesday next week, I will put on Blackboard your grades before final, your average grade in the course before the final exam. So you will decide whether you do the final or not. That was why I kept using Tuesday, just because the project is due on Sunday night. So, and I don't see myself finishing grading all the project on Monday. I will give it, believe me, I have all kinds of wine and champagne and coffee and everything. I'm going to just keep pouring cold water on my head and grade. As soon as it closes at midnight, I'll just start to grade. And I'll grade nonstop until I finish, okay? Maybe take a quick nap here and there. So this is the last class. The final exam is next week, Thursday. But again, do not take my word for it, because I did not make up the final exam schedule. It's the provost office that make it up. So the way I checked it, you guys can also check. I have nothing to do with setting up the final exam schedule. Professors don't have a thing to do with it. It has already been set up by the provost office. I checked it, and hang on, let me show everybody. I brought it to class just in case. Let's see. I downloaded it from the provost office.
Professor, while you load that up, do we still have the chance of not taking the final if we have a satisfactory grade before that?
Absolutely. I'm getting to that
Okay.
in a few minutes, buddy.
Okay, thank you.
Yes, I'm getting to that clearly. Just give me a second. Gosh, I downloaded that. Okay, academic calendar. No, this is not the one I want. Anyway, I don't know why I'm not seeing it now. But hold on, let me just give me a second, guys. Let me check academic calendar. But I don't know how many of you have checked, but the exam is on next Thursday from 6 p.m. to 8 p.m. Let's see, do I have a... Sorry, I don't have it here. I thought I brought it to class to show you, but you guys please check, okay? So it is next, if you want, I can send you an email maybe over the weekend reminding you or sometime. So it's next Thursday from 6 p.m. to 8 p.m. because we are regarded as online synchronous. That is, for the whole semester, I teach from 5:50 to 7:05. You guys come to class and we do it on Zoom. That's synchronous. So all synchronous classes, they gave us a schedule on the exam, and Echo 4051 is next Thursday is May 20th from 6 p.m. to 8 p.m. So it's 2 hours. Okay, and maybe some of you will maybe also have an exam after that from 8:15 to 10:15. I don't know. But for this class, yes. Okay, yes, it's May 20th from 6. You know what? Just hold on. Let me bring it up. Just to show you, I have it here for sure. But I didn't want to go back to my directory. Where the heck is that? Just hold on, okay? So I shouldn't be checking it for you, but that's okay. That's okay. As a professor, I had to check it myself because the provost office does not allow us, and they give us a big warning about doing final exams outside of the scheduled time. I can essentially lose my job if I did it. Okay, so this is it. This is on page 19 of the document. Look at the bottom right hand here, is page 19. You see here, Echo 4051. Everybody see that? This is our class, PTRA. That is Thursday, May 20, from 6 p.m. to 8 p.m. Are you looking at it here, guys?
Yes,
Yes.
we could.
Okay, so this is our final exam, Echo 4051. All right, but please check it yourself if you doubt it. But it's next Thursday, and it's 2 hours. Okay, it's 2 hours, and because it's 2 hours, it's going to be just. Some students have asked me, Professor, what are you thinking of for the exam? I'm thinking just like the midterm exam, the same format. It's going to be multiple choice because I think you all like multiple choice rather than solution of problems. So it's going to be multiple choice. I'll have something like 40 questions, 40 because it's 2 hours. And the questions will come from chapter 1, chapter 2, and chapter 4. Everything we have done. I will not ask you anything we have not done. Chapter 4, I think I recommended you read the first 5 sections, right? I recommended that on the first day. But when you read the first 5 sections, read only what we have discussed in class, okay? And sections 4.1 to 4.5 are pretty much what we have discussed in class. This section that I introduced today on the exponential Gotch and the threshold Gotch, I will not ask you to identify any R session, any results from an R session, because I didn't show you that in class. I just discussed the idea of leverage. the differential impact of good news and bad news. So if I have a question, it will be totally qualitative. It will be, this model Egarch is used for this, or what is Egarch used for? Something like that, A, B, C, D, something like that, okay? So that's chapter 4. Chapter 3, I'm sorry, nothing from chapter 3. Chapter 2 is the big chapter we focused on this semester because it had a lot. In fact, I didn't even finish everything. And then I skipped to chapter 4 because there are many more things I couldn't do because I needed some math background with you all. But for what we have done in chapter 2, the exam is fair game. And then from chapter 1, from what we have done. So the final exam will be chapter 1, chapter 2, and chapter 4 to the extent we covered, okay? And there'll be 40 multiple choice questions. Well, when I begin to make it up and I think it's too long, then either I give shorter questions or I reduce it to maybe 32 questions or 35. So please allow me to use my judgment in terms of time, because for final exam, I don't have, I don't have flexibility about to give you guys extra time because it's a Thursday and we are the first from 6, we will be the first evening exam from 6 p.m. to 8 p.m. Usually there's another exam from 8:15 to 10:15. And we are told to assume that people in our class will be taking the other exam. Okay, that's a safe assumption. So I cannot give you more than maybe 5 extra minutes because you guys, anybody taking 2 exams on that, you need your head to cool down before you go to the 8:15 exam, okay? So when I begin to make it up and I make up 40 questions and I think it's too long for the 2 hours, then I'll decrease the number of questions. So even though I'm saying 40 questions now, it may be 35. Okay, you understand, right, everybody? Okay. What else do I need to say? All right, any questions on the final exam? I'll need to make a couple other announcements. And then if you have more questions on the final, you can ask me. There's really nothing to review. I will review if you want me to, but there's really nothing to review, okay? Because everything you have captured in your homework and you have captured in class, and it's going to be like the midterm exam. So if you have any questions, you can let me know. I'll answer the questions, okay? Let me make a couple on about the project, okay? I don't know if you guys have checked, but I have posted the homework redos. Okay, if you go on Blackboard now, you can see your grade for all the homework assignment. I think 1 or 2 of you have issues with your homework, so you couldn't see it, okay? But I'll deal with that later. But I don't know how to say this, but this is one time you guys are going to see the bad part of me. The idea of having you not take the final exam, the ability for you not to take the final exam, or the opportunity for you to not to take the final exam, is entirely due to me. Okay, it's I'm offering you that because I think you have worked hard during this semester. And if you have worked hard during the semester and you do this project, and then I aggregate everything and average, and you look at your grade and you say, oh, whew, I have an A going into the final exam. Why would I go into the final exam and possibly mess it up? Then you send me an email saying, Professor, I'm happy with my A. Some people are happy with a B. So if you have a B and you want not to take the final exam, that's okay. Just send me the email and say, Professor, I like my grade of B. So it's up to you. And then you will wait for me to reply to your email. So you send me an email and wait for me to say I got it, and that's okay. Okay. So why am I saying this? Because this is something I feel. Maybe you don't feel like that. I feel it is generous of me to offer it to you. You may not feel like that. That's okay. Okay. But I want to say this. Everybody in this class, please look at my face. Because my experience with regrading homework is because some of you, a number of you, submitted after the deadline. Now, if, I don't know how to say, because sometimes I cannot look serious, but this, you can take it to the bank. If you submit your project late, then you are taking the final exam. Let me say it again. It is being recorded. So do not say I did not warn you. If you submit your project late, automatically, whether you are making an A already before exam or not, you will take the final exam, for sure. And if you decide that, oh, professor, I already have an A before final exam, and you don't show up, you get a 0 on the final exam, and you definitely not make an A in this class. Let me repeat. The opportunity I'm giving, I'm offering you not to take the final exam is conditional, totally conditional on your turning in the project before deadline. So let me just use some, if James in this class, I don't know if James in this class definitely had A's in homework and A in the midterm exam and everything before final, and your average is an A before final, and you submit your team project late, you have to show up for the final exam. And if you don't, you get a 0. And that 0, I will average, and that will push you away from an A. Why? Because it's unfair for you not to submit your project before deadline. It is very unfair because look, I'm giving myself 24 hours to grade the project. And remember the other day, was it Roxolana or somebody asked for maximum of 4 pages. So I'm anticipating that rather than 1 or 2 pages, that many of you will write more than 3 pages. I mean, you try grading this project 4 pages and all the illustrations and graphs and R, because I look at each one within 24 hours. So it is non-negotiable. Guys, I beg you, do not say Blackboard froze around the time the deadline was coming. If, I don't know how else to say this, begin to submit 6 p.m. on Sunday, just in case Blackboard will freeze. Because if you submit, once it closes at 11:59, then for sure you're going to do the final exam, okay? Did I make my point? I'm trying to look serious and sound serious, but I'm laughing because I know that some people in this class always push the envelope. This is one time you push it, you are taking the final exam, okay? Okay, all right. So I beg every one of you, I'll be truly happy if everyone submits before the deadline and I grade, and the whole class, you all have an A going into the final, and you say, Professor, we love you and all that, but we're not going to take the final. We want our A. Trust me, I'll be happy to give everybody an A in this class. But I beg you, do not push the envelope. And I know the names of people who have been pushing the envelope in this class, in homework 1, 2, and 3. I know who you are. I know your names. Don't do it this time. Because if you do it, you are definitely going to take the final exam. And the final exam, I tell you, if you take it, then it's a kind of, how do you say, it's a gamble on your side. Why don't you do things properly, turn in your work by deadline, and at least give yourself a chance for not taking the final exam, okay? I hope I'm clear. This is being recorded so that there will not be an issue. Oh, Professor, you didn't tell us. All right. Okay, sorry, I'm done preaching. It took a while to preach. Okay, so who had their hands up? Somebody was going to ask me a question. Who's that?
I had my hand up, Professor.
Tobias, that's you. Yes, thank you.
My question was for our redo, is that going to replace the?
Yes. Whatever, if you redid a homework, let's say I noticed some of you got like 50 out of 100 for homework 3, and then you redid it and you got 100. Yes, then 100 will be your grade. If some of you got 90 for homework 1 and you went on ahead and you redid it and you got 100, then your grade will be 100. Okay. So before I post your grade next Tuesday before final, I will do all those replacements. Okay. All right. Are you?
Sounds good. We're clear. We're perfect.
Okay, that's your question. Okay. Yeah, I'll do that. So that's another. I think that's another something good I offered you, especially for those. Many of you did the homework, but you got a low grade and you redid it. That's okay. But the ones I have a problem with are those people who did not submit. Okay. Some people didn't submit because they were sick or something. I give them special permission. Okay. But this time I'm not giving special permission. That's why I'm asking you, please begin early. And you have a team member. So if you are not available to submit, your team member has to submit for you. So this time I'm not giving any special permission for anybody to submit late. If whatever happens and you submit late, that's okay. Then you are taking the final exam. That's okay. Okay? All right. Questions? Questions? And guys, I want to promise you that I will really bust my tail to grade the projects as quickly as I humanly can. Usually for homework, the TA Chan helps me. Sometimes she looks at your codes and she verifies the code, and sometimes I look at it, or sometimes she helps me grade the homework, and she and I, we use a grading answer sheet. I make up an answer sheet and so on. But this time, because she's a master's degree student, and she's very busy with exams, and she usually offers to help me, but I don't have the heart to ask her to help me to grade a day before she takes an exam or two. So she's busy studying now. And even though she's offering, she doesn't know this. Please don't tell her. I'm not even going to talk to her until she finishes her final exam. Okay. She doesn't know it yet. So I am going to do everything in my power to grade this project in 24 hours. I know it's going to be tough, but because if I can get you your pre-final course average on Monday evening, and so you can make a decision, that means you have many more days not to study this class and put it for your other class. I'm aware of that. Okay, so I promise you I'll give it all my all to give you the grade as quickly as possible. Having said that, I beg you guys, can you just trust me? Okay, I know many of you don't usually trust professors, but I beg you to trust me. Just leave me the heck alone. Don't send emails. Professor, I haven't seen the grade you promised us. And typically, it is those people that normally submit late that will say, Professor, I just submitted a redo. And once they submit it, like 2 hours later, Professor, I haven't seen my grade. So can I ask everybody, after 11:59 on Sunday, can you please leave me alone. Don't send me email, because every second I take to read the email and I sit down to answer takes me away from grading. Okay. So unless it is a humongous emergency, please don't write me an email, because I'll be totally focused on trying to get you your pre-final exam grade so you can make a decision. Okay. It sounds also funny, but I beg you, I'm not demanding. I'm just begging you. I'm pleading with you not to send me an email. At least give me until maybe until Tuesday noon. Okay? All right. Just get some wine and chill. Yes. Yes, everybody chill. Okay. Any questions?
Yeah, so Professor, just a question.
Yes.
So like come next week after Sunday, and when you're in the process of doing the grades, how should we notify you, and how should we let you know whether or not we're gonna be taking the final exam? So like we
Okay.
we notify you so that everything works out smoothly and there's no
Ifs and buts.
Say that again, I'm sorry.
There's no if, when, and but, right? Yeah, there's no question. That there's no uncertainty, right? So let me tell you what I usually do. So the project is due on Sunday 11:59, not midnight. By midnight is too late. It's 11:59. It closes. 1 minute later, I begin to grade. Okay.
Right.
Okay. I begin to grade. Let us say positively, because all this Sunday I'll be relaxing with wine and champagne and coffee and sleeping and watching movies. But right after it closes, I'll begin to grade.
Right.
By the way, those people that submit early, I'll also begin to grade before. Some of you have told me, Professor, I plan to submit on Friday or Saturday. If you submit on Saturday, I'll begin to grade. So I'll just begin to grade after the deadline. And if I can finish by Monday evening, say 9 p.m. on Monday evening, then I take a couple hours break and then come back and do the averaging. Joseph, I'm talking to you, I'm doing the averaging. And at the end, I take a break, I look at it, I look at all the cost averages. I curve if I need to and all that, and then blah, 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 blah. So by maybe midnight on Monday, I post the grades. And once I post the grades, I'll send everybody an email, just like I normally send you email. I'll send everybody an email, say the pre-final course grades are now available on Blackboard. Take a look at it and make a decision whether you take the final exam or not. If you decide to take the final exam, no. If you decide that you don't want to take the final exam, that your grade is satisfactory, then you must send me an email. So if you say, oh, this is before the final exam, professor is saying that my average is B, and this is all I need for this class, I don't need to take the final exam to take a risk of going to below B- and C. So you send me an email, Professor, I like my grade. So don't just say, Professor, I like my grade. Professor, I like my grade before the final exam. I will keep this grade, and therefore I will not take the final exam. You can tell me, please confirm. Then I'll look at it. I'll check off your name in my Excel spreadsheet, and then I'll bounce back the email to you. I say, okay, got it. Congratulations, blah, blah, blah. Keep in touch, blah, blah, blah. That's it. I won't see you again for final. Is that okay, Joseph?
Yes, I just wanted to know, because I remember you said you don't want anybody taking it for no reason, and I wanted to make
No. Okay, that's a good question. But when I said do not send me an email, I'm referring to between the time the submission deadline on Sunday and the time I post the grades.
Right.
Because some of you are naturally, you are excited or nervous, or just you want to know your grade. I'm like that. So you want to, usually when you submit, you say, Professor, I haven't seen my grade. What's going on with you? Just leave me alone until between Sunday midnight, when the deadline, and when I post the grades. I'm just saying, everybody, please trust me that after the deadline for submission and before I post the grades, I'm doing nothing else but grading the project. That's all I'm doing. I'm just asking you to trust and believe me when I say so, okay?
Got it.
Okay.
Yeah, thank you so much. It's honestly very lenient and
All
helpful.
right, Tobias, it's okay. I mean, at the beginning of this class, I must say I was worried about performance in the class, especially in the first few weeks of class. And when I began to give homework assignments, I think we all got better. I got better, you got better, and the class began to be fun. Yes, it's a lot of work doing the homework. I agree. I truly apologize for it, but I think it made us learn a little bit more, but it made us keep up with the class. And that is why I said, okay, let me make this offer of resubmission of homework, as well as the opportunity not to take the final exam, and give it a serious thought. If you're okay with the grade or happy with the grade, then don't take the final exam. Just devote that time, that extra day or two, or extra half a day that you would have been studying for this class final, devote it on some other class that maybe you need a little bit more time. Okay, when I was a student, I think just one or two professors gave me this opportunity, and it made a difference in my other classes. When I was taking my MBA, my God, I hated classes like marketing, org behavior, human resource. My God, I didn't really know what they were talking about. So for exams, I always spent a lot of time studying those classes. And I appreciated professors that gave me, especially for like finance or statistics or econometrics. I could easily, do away with not taking the final. Not that I made A's, but I was always okay with my grades, so that I gave extra time to classes where I was a little bit weaker or where I needed more time. So that's essentially what I'm offering you, okay? All right. So if ask me any question from now till 7:30 on the project, on many of you have been asking me questions on the project, and I've been kind of answering by email. And so if you, after tonight, if you still have a question on homework, you can send me an email. I'll try to refer. I think a couple of you had questions with data, and I kind of gave you some hint, and it worked for you. So again, please, I beg you, you and your team member, don't wait till last minute, please. Okay. I know like 5 teams already finished the homework, the project. You already finished, and they've written up most of it. And I advise them to read again and make sure their report is well written, that it is sequential and all that. So please don't leave it to the last minute, because I think it will make a difference between submitting on time and not. If you don't submit on time, then you definitely take the final exam. Okay. And I think you want to avoid that if you can. That's all I'm saying. Hi, Lily. How are you? You haven't talked to me. Are you pissed off at me today, Lily?
No, I'm not. I'm not gonna lie. I'm very stressed about the project. I've been having coding issues, so I'm just
Okay.
I'm just being anxious.
You have questions. I know last class you were a little bit pissed at your favorite professor.
I'm glad we cleared that up, honestly, because okay. I would have just used completely wrong data for the project.
Okay,
not at all.
My students really get pissed off at me. Then when I see them after they graduate, they say, "You son of a gun or not, come," and I make up by buying you a beer. Okay, so I'm sorry if I piss off anybody in this class, but I'll buy you a beer when I see you, or wine.
I will hold you to that.
Believe me, just in August or September, after August, all of you come look for me. I am buying. I'm a poor finance professor, but I am buying for you because of all the hard times I gave you guys in this class. Even Danny gets pissed off at me from time to time. All right.
We love you.
I know. I love you guys more. Okay.
I'm gonna miss this class. I'm not gonna lie.
I know, but it's a tough class, but I think you guys were fantastic.
I appreciate that. I hope you grade us that way.
Yeah, no. Believe me. This is one class I will not blink if all of you make an A. Trust me. I will not blink. I'll be happy to give everybody an A, but you have to meet me halfway. But even if you don't make an A in this class, whatever grade you make, you must trust that that is the best combination of grades you would have made. Let me give you an example, okay? Nobody has asked me so far. On the syllabus for this class, I said there will be 2 projects, remember? But I changed that way before spring break, before the middle of the semester, because I noticed that many of us were not pulling our weight the way I wanted. I'll come to class and only a handful of you know yourselves, were always asking me questions and interacting. And then sometimes some people will email me questions, and it was obvious that they were not following what was going on in class, even though they were there. So that's why I began to give the homework. And many of you were really angry with me with the homework. But I'm a big boy, I can take it. I'm not your professor to win, how do you say, a beauty contest. That's not my concern. But when I began to give homework, then those of you who would have blown off R or would have, you sat up, okay? And that was good for me. And then I gave you you guys don't know how surprised I was with your performance on the midterm exam. I mean, I was just oohing and eyeing and backslapping myself when I graded that. I'm saying to myself, wow, these people surprised me. And some of you were not impressed with some of you didn't make 105%. Some of you made like 92, and you were still angry at me. And I said, are you kidding me? I expected you to make an F, but you made a 92. So I'm kidding, of course. But after your midterm exam, I was so blown away with this class, believe me. So that's when I said, okay, things are looking good. Yes, the homework is annoying. Yes, this second project is annoying, but it's for a good cause, okay? So I apologize if I piss you off, but that's okay. It's how do you say? It's an equal opportunity pissing off.
Professor, I have a
I
question.
didn't single out any one of you. Wait, Andrew, hold on. Alec, you have your hand up, and then Nadia.
I think Nadia was first.
Okay, Nadia, I'm sorry, Nadia.
Thank you, Thank you, Alec. Yeah, but I have like 4 questions. Maybe if someone has like one or.
You want to ask me?
I have one.
Okay, who has one?
Alec.
Alec, go ahead.
Yeah, so Professor, on the homework, I mean, the group project, you asked for the QQ test. Is that the QQ normal that we have to compute and then compare it to the straight line, the fitted line?
Yes, that's it.
Okay.
That's it. And that one, even though I haven't said it, I'm going to use that as extra credit, okay? Because I didn't really teach you that in class.
I had to Google it.
You're supposed to have learned it in Echo 4000, or you Google it, that's fine.
Okay, thank you.
If you do it, that's extra credit for you. I just didn't mention that in class, but because I didn't want, but I expect everybody to do it because that's cheap extra credit. Just Google it.
Right.
Okay.
Yes. Thank you so much.
All right.
Thank you, Nadia.
Go ahead, Nadia. Sorry.
Yeah, let me ask.
Andrew, you have one question?
I will start.
Andrew, you have one question?
Yeah, I have one question. So when I import the data, I always get this XTS error. And can you explain to me what I believe the error is something like
XTS, isn't it one of the packages for the time series?
It said for a chart series you need it to be an XTSable form. Not exactly what the error says.
Okay, try and see if you can download the package called XTS.
We actually do have the package downloaded. So we've converted the data into
CSV.
Yes, CSV was the initial file type. Basically, we then converted that into like time series.
Yes.
The issue that we're basically having is that the data that it's calculating for us is actually the years and not the actual data. So I don't know if this is maybe some specific sort of format we should add after the function in order to tell it to be calculating off of the numbers and not the years. Like like, for example, when we use basic stats and we run all of the moments of, the statistical moments, it's actually giving it to us based off of the years. Do you see what I'm saying?
So it's giving you the mean of the years.
Yes, exactly.
No, but remember, when you read the .csv file, when you convert to .cs, and by the way, there are 3 types of CSV extensions, right?
Yes.
The one you need is CSV, is the comma delimited, right?
Yes.
Okay. So if you read that into R, then you remember the command I used with my GDP database. I said, put into Y, the parenthesis, comma, blank, comma, GDP. Remember, and it goes and extracts only the GDP, right?
Yes, we do. So I would do like almost like a bracket,
yes.
comma, and then my column is called D2. So I do whatever.
Yes. So if you do that, is it still calculating the years for you?
Yes, unfortunately. I'm not sure that, we've really tried everything here. So I can even put like how, like, the exact in the chat what our last thing is in terms of I basically just sent, that's like our data set going on there, in terms of converting, like, it's already a time series at that point. This is basically telling it to take that column, and it's still not in that column, unfortunately.
So if you give it that command, then it's not,
yeah, like
okay. You see how you take the parenthesis here is you're using bracket, square parenthesis. You need to use the normal parenthesis, right?
Okay.
And then when you open the parenthesis, you see how you say, okay, let me type
exact. So you want me to add a space before the comma? Is that
yes, you must add a space before the comma.
Okay, that might be where we're going wrong.
Yeah, that's definitely it. At least from what I see. Okay, so Lily, I'm copying your program and I'm going to text it back to you right now. I'm going to chat it back to you right now, okay? And I'm going to tell you what I would do. Again, look, you guys look at me, I'm the professor, and many times you have to play with this, okay, depending on how tired you are. And yes,
we're on a call for
absolutely
many hours.
Believe me, I spent lots of time, okay? So somebody emailed me the other day and I brought him to Zoom and I didn't really do a thing, just he and I talking, he was able to figure it out. I didn't really do a thing, but sometimes you do it alone or you call your team member and you walk through, you talk it through, okay? And if it's really bad, you can email me. So, so Lily, this is what I'll do. I'm sending it back to you now. Not to Nikhil, I'm sending it back to everyone.
So I just tried to run it and it's giving me the same thing. Andrew, I'm not sure if you've tried to run it with a space in it.
Here, so I left a space there and I used the normal parenthesis, not the square one.
Oh, it's okay, the regular parentheses.
Yeah.
Okay.
Try that. I mean, it depends on the package. Some packages may require you this.
I have all of the packages running. So like I have everything possible.
Lily, so yeah, I believe you. Huh?
Tell me there's unfortunately an error here. I don't know.
But isn't the data supposed to be yearly?
Isn't it supposed to be what?
No,
yearly.
Yearly, but in terms of like the mean and like the return, we're trying to get the actual returns.
Now, when you remember when you read the data in as CSV, you remember in my class example, I said beginning 1970 and frequency 4, remember? Your frequency should be 1.
Yeah, that might be.
And in fact, wait, hold on. Let me. Okay, hold on. Let me show you guys something. Okay. Let's see.
When I change them to regular parentheses, everything freaks out.
It freaks out.
Yeah. It's not even. It won't run. It's saying it can't find my data set now because I think it's assuming that I'm adding something else into it.
Okay. Let's just hold on a second. Let me.
It will run with the square brackets though.
Okay, so use the square bracket. Let's see. Hold on a second. I want to show you something. Folder. Sorry, I'm just bringing up a file for in Word document, and I'll show you in a minute.
No, that would be fantastic. Because really, like, we have all the code down for like all of like the bulk of everything. It's literally the most basic thing we're having issues with. So
usually that's what you have problems with.
I know it's frustrating.
The complicated things you do well, but the basic thing, I make a lot of mistakes in the basics. So that's why I understand where these problems are coming from. Let me just show you something.
But why do you have to specify frequency when you
that's exactly what. Thank you, Alec. That's exactly what. That's exactly what I want to show. Thank you. You read my mind perfectly. That's exactly what I want to show. Okay.
So I do need to specify the frequency in when I'm trans.
Okay. Look. This is one of the programs I use. I for AIC and all that. Lily, look at the 1, 2, 3. Look at this command, the third line, data 1. You see that?
Yep, I do.
Equals TS, then data, then comma, start this, start that. Now
start 9 and then frequency. So why is frequency 4
there? Because the data I gave you, this GDP data is quarterly.
So this should just be 1 here?
In fact, don't even do 1. You know what I'll do? I'll
delete all of frequency?
Yeah, look, you see this close parenthesis?
Yep.
I will just move it to right after this A.
Oh, see, that's what I was doing. That's what we've been doing.
So this would be, so this would be data one, okay, equals, and I normally use equals, or you guys can do what you're doing. You do. I have a neighbor that runs this ATV, altering thing, and the guy is just bugging me when I'm teaching. It's so loud. So if you guys hear some motorbike, it's him. Data. So are you looking at this new line?
Yes.
This one? Yeah. So that's how I would do it.
Yes, that's how we've had it. Unfortunately, I really wish that was the solution. Like, it doesn't make sense because we've done the simple returns by hand in Excel. They don't look like that.
Wait. What do you mean?
So like our first yearly return is -50. If I do that by hand, it's like a -1%. So it's like very far off. So our chart is weird. Like,
I mean, I mean, there's something wrong. Okay.
There's something wrong.
Yeah, there's something wrong there. Okay. Lily, look at this equation here. Y equals data 1. So actually, you need the square parenthesis. Sorry.
You need a square, and you don't have a space there. So
no, I don't have a space, but you should have a space. So that is automatically something that I try to correct.
Yeah.
Okay. So no, it should work like this. That you are missing something. Maybe you are missing you use group 2, right?
Mm-hmm.
What is your group? What is that group 2? Is that the time series data group 2?
Yeah, so the group 2 is the time series data. So I've transferred, the CSV file into time series, and group 2 is that.
So what I call data 1 here is what you call group 2. Look on this line here.
Well, actually, my group 2 is actually your data. You see it?
Is what, the annual data?
Yes. So it's the other way.
So okay, but look, see what I did. Are you watching this?
Yes. So your data one is our group 2. Yeah.
So my data 1 is my time series of. So yeah. You can think of the original data I sent to your team as my data here.
Yes.
And then I made it a time series. I declared it a time series, and I called it data 1. Are you with me?
Yes, got that.
Is that what you call group 2?
Yes, that is group 2 for us.
So your group 2 is your data after you have this declared it as time series, yes?
Yep.
Okay, so that's correct. So this should be, so this should be group 2. So your command was good.
So yeah, our command is good. So then I created another variable doing the brackets, and specifying what column I wanted to take it.
So in this case, you specify like my y here, right?
Yes.
Okay.
I called it like,
so I think your problem, you and Andrew, right? You're in a team together. So I think your problem is maybe when you're trying to calculate the return.
Mm-hmm.
So check the equation for your return. You're doing something wrong there.
Okay.
That's where it is.
You think I can, so in terms of your y here, what we've calculated as y, you can use that y to find the returns though, right?
Yes, that's what I used to find the
Right,
returns.
yeah. So I don't know, maybe it's our simple return calculation, but
yes, again, I would check. Now, okay, hold on.
I think
Now,
even if I
hold on, Andrew and Lily. So with this y, you calculate 2 types of returns, right? The log returns and the simple returns, right?
Yep.
When you calculate the log returns, are you having the same problem?
Same problem. So it's basically giving me very similar returns. I know log and simple aren't too far off. It is very extreme.
Okay, so you need to check your formulas for converting to return.
So converting to return. So really what I'm using is the yearly return function, adding in what year y is and multiplying it by 100. It seems.
You know what I would do if I were you? Again, out of desperation, you know what I would do? I would go to Excel and calculate the simple return and the log return.
We have.
And then CSV each one and bring it in.
That's what we did. Is that fine for the project, Professor? Because we didn't know exactly. We had kind of the same issue as Lily did. So we just calculated it in Excel and then brought that CSV file into
R, and it worked, right?
Yeah, it worked. But in the question, it's like says
that's okay. That's okay. Just let me know that that's what you did. So Lily and Andrew, that's what I would do.
So maybe that's the route we're gonna have to go down because we're too deep in.
Yeah, Lily, we had the same exact problem. So like we did the CSV. So maybe that's the solution.
Yes. So I would do again, just be creative. I know what I asked, but if it's giving you too many problems, do the same thing on Excel and then bring it into R and then continue in R. Okay.
Okay. All right.
Yeah. I think that's really better instead of just being frustrated and wasting your time. So do it on Excel, CSV it, and then bring it in and then continue. Good.
I have a question, Professor, about handling the data. Lily, are you done with your questions? I don't want to.
All good. Thank you.
Okay, good job, Lily.
I have a question about handling the simple returns. So for the first return, it should be like I get a weird R error if the simple returns, the first simple return is not 0.
Well, so what you can do is, again, many of you did that for homework. That's a command in R you can use, or if you don't use that command in R, if you do the simple returns, Tobias, in Excel, then you have to delete the first line.
Oh, delete the first line. Oh, right. All right. Because yeah, you get different results if it's 0, obviously.
Yes, a couple of students just kind of just bugged me at homework time, and I said, okay, I sent them a Zoom invitation during the week, and then I was just looking at. I said, what the heck is wrong? These students are doing everything correct. And then suddenly it hit me because why? I've had that problem several times before. But there's a command in R, and many of you found it for homework. There's a command in R that will automatically drop the first line. But Tobias, and Lily and Andrew, if you do it on Excel, then you remember if your first year is 1990 and your second year is 1991, then your return would be for 1991, right?
Exactly, yeah.
Because you don't have a return for 1990 because I didn't give you 1989 data, right? So once you calculate the return beginning from 1991, when you finish, get the column for returns beginning 1991, then you have to go and delete the column for 1990, the row for 1990.
Perfect. That makes sense.
And then CSV it read it into Excel, read it into R, and then continue your work, okay? Okay, you got it?
Yeah, that makes perfect sense.
Okay. There are many of you in this class. I'm hearing only questions from Danny, from Tobias and Lily and Andrew. Nadia, are you good? You have your hand up, Nadia. Okay.
No, not yet. Not yet.
Okay.
I'm still sitting here with my 4 questions.
Okay.
But it's okay.
Sorry, I kind of forgot about.
No, no worries.
Okay.
No worries at all.
Okay.
So my
So
first
go on.
question.
Go on. Yes, go on.
My first question is about question 9. Do you have it in front of you, or you want me to read it?
Are you kidding me? I have it ingrained in my brain. Okay, no, I'm kidding. Let me go get it. Can you read it to me, please?
Right. It's asking, do these simple returns appear to come from a normal distribution? And they're like, you want us to plot a QQ
Yes,
plot?
I want you to do it 2 ways. QQ is your eyeball. QQ is an eyeball, right? And
then
then
Jarque-Bera test
is the statistical test.
Exactly. And then you want us to explain, so make a conclusion. Do we have to use Jarque-Bera test results to explain?
Both. You have to explain
both.
the QQ and then the Jarque-Bera. You guys can handle it.
Okay, I got you. Then question number 2021, it's asking about printing and plotting AIC values over the 12 flags. So I was a little bit confused in this part. Do we have to go over 12 flags, or we using only 12 flags?
Use only 12 flags.
Right, because the wording confused me.
I know. Hey, I'm just a professor.
Okay. Last but not least, number 24. It's test for arch effects, and we got 2 codes from you for arch and Gauche. So we have to use only arch for arch.
Yes.
Effect. Okay.
The one that says arch test.
Got it. And overall question. So if the results of simple return and log return a bit like different from each other, and for example, we have to like for example, doing Jarque-Bera test, we have to reject the data in simple, like we have to reject the null, right? But we don't have to reject the null for log return.
Okay.
Is it all right?
And you think it's crazy, it's wrong, and why would you think it's crazily wrong if you did everything correctly?
Because I always been like accepting return, like the regular return and log return, like quite similar. Just log return is more precise.
Okay, if that is the case, then go back and check your commands and check your work. Okay. Just check your. I mean, one of you run it, the other one check it. That's why you're in a team. Okay. I'm not saying it's right or wrong. If both of you have checked it and the same answer holds, I mean, that's what your data is telling you.
I got you. I understand. Also, I got a comment from you from my homework 1 redo, where it was like a comment where you say,
"What are you thinking of?"
See me? No, I can explain myself. It's just like my wording was a little off, but
exactly.
I do understand.
Hold on. That is where I will have a problem with you in your report. Okay. Now let me say this in the best way I can. Many of you, when I talk to you in class, you talk to me like normal human beings with one head and me one head. But then when you want to write up your report, it's like, who the heck is this? I don't know. Is this Nadia or is this a monster from Mars? Because many of you try to use technical language. Nadia, you see, just like you're asking me these questions, right? It's like we're all having coffee and you're talking. I'd never asked you, Nadia, can you repeat that question? Because you are very clear and articulate, right? But then when you go to write your report, it's a different Nadia I see. And sometimes the thing that I know you know, look, I trust all of you in this class. I know you know what you're doing. But then when you guys go to, are you trying to impress me with your technical language? Don't even try, because I'm not impressed with technical language. I'm impressed with your everyday language. Just talk to me like you're talking to me right now, okay, Nadia? So for that homework,
Yes,
I said see me because I wanted to give you this message. Whenever you ask me questions in class, Nadia, I never have the problem understanding you. But for that line for your homework, I'm saying, this must not be Nadia. Some alien has.
No, when I was writing, I understood myself, but
Of
then
course you
I
understood yourself.
read it and I'm like, probably,
yeah.
it was like confusing for you.
In fact, somebody said,
Okay.
I don't know if it's you or somebody said, everybody please listen to me. Null hypothesis, they gave me the correct null. It's like, let's say null hypothesis, the null hypothesis, the distribution is normal. Alternative, the distribution is not normal. And then, professor, I got my p-value is above, my p-value is above 0.5. Therefore, the distribution is not normal. If your p-value is larger than 0.5, that means you fail to reject the null. Quote unquote, you accept the null, that the distribution is normal. What? All right. Andrew, no. I want to thank you guys for the great semester because I had a lot of fun. It was frustrating sometimes, but you guys were great, okay, everybody? So hang in there. It's not over yet. Submit on time and then trust me to do my thing, okay, Andrew?
All right.
Okay, bye now. And in August, pass by Baruch. I'm buying the beer.
Okay, you owe me a lot. So
I know, but the first
all
drink,
on you.
The first drink goes to Lily because I pissed her off a few times.
If Lily's not there, we could start. Don't worry.
Okay, we can start. Okay.
Love you, Professor.
Good luck on your
Shiji.
Shiji. Good luck on your final exams. Okay, everybody, and those of you who are graduating, congratulations.